Fun science video for you. In class, we've been learning all about energy transformations and energy transfers. And this week, we are focusing on what I call the potential energy challenge. And what's going to happen is I'm going to be showing you at the end of the week tons of different pictures, and you're going to have to figure out which type of energy it is. So today, you're learning about what's called gravitational potential energy, and you're learning about something called elastic potential energy. So I thought we'd start with gravitational potential energy and show you lots of fun examples from your life. So last week, remember, we did something with a ping pong ball. So if this ping pong ball is here, all right, it has some gravitational potential energy because this is off the floor and it took some energy to get it up here. But if I bring this up, now it has more. And so some of that gravitational potential energy we can show when it bounces and comes back up. But if I come up higher, which I give it more gravitational potential energy with a greater height, of course the ball will bounce higher. So when you're on a roller coaster, and here's my kind of example for that. Instead of a roller coaster, I have this little car here, all right? And when you're on a roller coaster, you might recall and you might remember that a roller coaster, the very first hill, has something that's pulling you up. A lot of times that's a chain. And that chain is usually attached to something that's giving you some type of chemical energy. And it's transferring it with that chain to the car, and it's lifting you up on a backside of a hill. And when you get to the top of that hill, the rest of that ride, unless there's another point where they add more energy, is all on gravitational potential energy. And so when you're trying to go through a ride like that, you'll notice that the second hill is always lower than the first. And that's because you're losing gravitational energy as you go. You're also losing some energy to friction, although roller coasters are designed to have very little friction. And so you're not losing a lot of energy to that. But that's why the second hill is always smaller. One of my favorite roller coasters is the Beast at Kings Island. It has a point in the ride about halfway through where it needs to give you more gravitational potential energy. So it gets another chain and it pulls you up another thing halfway through the ride. But if something doesn't have enough gravitational potential energy, it won't make it. So we have this loop here. Well, obviously, if I start this car lower than that loop, it's not going to make it through that loop. But if I give this car a greater amount of potential energy than what we started with, so we'll go ahead and do that right here. We'll give it a greater. Now we can see that this is above that loop. And so this, oops, if it doesn't hit my finger on there, sorry, let's do that again. This should go through now, and it does. And so that is gravitational potential energy. Now my camera person, we're going to switch a little bit. He's going to kind of come over, and we're going to keep doing lots of different types of energies. And what we're going to do is we're also going to be talking about energy transfers and energy transformations as we're doing it as well. So let's start having some fun. So first of all, let's think for a second about that whole idea. We've been talking a little bit about gravitational potential energy. So let's do a little bit more with gravitational, but let's also start to talk a little bit about elastic potential energy. So here's a ball, okay? And this ball is going to do a little bit better job of bouncing than this. Well, why is that? Well, that's because this ball, when it hits something, all right, it also has this ability to be compressed. All right, so elastic potential energy is the other one you learned about today. And elastic potential energy has two main ideas. It has the idea of something either being stretched or something being compressed. So let's show an example of stretched. All right, so here is, for example, a toy that I bought my son when he was younger. And we got this in the Czech Republic. And what we do here is it attaches to the ceiling, and what you do is you pull this down and then you let it go and it kind of just bounces there. Well, at the top of this, we see a spring. And this spring, some springs are designed differently. Some springs are designed so that when you stretch them, they'll give you some of that energy to come back. Other springs are designed so that when you compress them, they will go back. So let me give you an example. Here's an everyday object that's got elastic potential energy. This is designed to suck some water or something out of something. So it's got elastic so that when you squeeze it, it'll go back. All right, so this one you compress it and it goes back. Some springs, when you compress them, they release. Maybe you've seen some of those toys that have like a suction cup on the bottom. And when you bring the spring down and it holds it there for a while, the suction cup on a table, and then when it can't hold it anymore, the spring kind of jumps up in the air. Well, a ball is similar. So I was talking to my video assistant earlier, and I gave him both of these two balls. And I said to him, I want you to squeeze both of these balls. And I said to him, one of these balls, when you squeeze it, it should feel like it's fighting you and it wants to go back. All right? So when you compress it, it wants to go back. But the other one, when you squeeze it, it should feel like it doesn't want to go back. They're both made of rubber, by the way, and they're almost the exact same mass. By the way, my assistant who's videoing is my son Samuel today, and he told me, had me put on the bottom, the one that he felt would not bounce as high. So let's see if he is right. This is the one he told me does not seem like it has as much elastic potential. All right, so he said when he squeezed this one, it didn't feel like it was really giving back. So watch, when this one hits, well, this ball, it's made out of rubber. It's about the exact same mass. It should have the same amount of energy as this ball, but when we drop them from here, what happens is this ball doesn't have that elastic ability, so that when it compresses, it doesn't want to go back. Whereas this ball, when it compresses, it wants to go back. No ball, by the way, gives you 100% return of your energy. But there's all kinds of examples of both of these types of things in our lives. So we've been learning, for example, about elastic potential energy. Let's show you some common everyday objects that maybe you've seen, maybe you haven't. So we got a rubber band, all right? Rubber band, when you stretch it, it wants to go back. Well, how can you play with that? Well, you can take it, wrap it around your finger like this, put it on the end of your finger like that, and now you have a little trigger so that when you release your finger right here, I'm going to short it towards the camera, and it gives back some of that energy. Well, there was also an energy transfer there, okay? So when I took this rubber band and I stretched it, I put chemical energy from my food, was transferred into mechanical energy in my hand, which was then stored as potential energy in this elastic potential energy. The bigger I stretch it, the more energy it has, it releases, and it gets back. Well, maybe you remember seeing these when you were a little kid, okay? We've got a little toy here. It's called a wind-up toy. Well, inside of a wind-up toy, there's a coiled spring. And that coiled spring, as you tighten it, it wants to uncoil, all right? And so what happens is when you wind this like this, you are tightening a spring inside of it so that when you do that, it releases that elastic potential energy that you gave it, which is kind of cool, all right? Now, in class, we've also been learning about how height matters with gravitational potential energy. Here's a fun little thing. Maybe you could build one of these if you wanted. You take a ball, like a little bouncy ball that you get from one of those machines outside of a store. You attach a straw to it with some glue. You make another straw that's a little bit bigger, and you make like a little rocket, okay? And what we'll do is this will shoot the rocket. Well, if I give this a greater amount of gravitational potential energy, so I drop it from a higher height, now this took more energy to get it up to that height. So now this position is greater. This ball now has greater energy. When it transfers that energy to this straw rocket, it should go higher, and in fact, it does, which is kind of cool, showing and proving that idea of that. So that's gravitational potential energy again as well. So let's talk about how can I make a ball bounce higher? Well, remember we were talking a little bit the other day about that as well last week when we showed putting a bigger ball and a smaller ball. But what if you also took a ball and when you bounced it, what if you could give it not just potential energy, but what if you could also give the ball elastic energy? So you've seen these are called poppers. You invert them like this, you put them down on something and they release, and when they release, they go into the air. Well, you've learned that you can't make a ball bounce higher than where you drop it from. It's not going to go above my hand. It's not going to go above my hand. But if I put it on this, all right, and I drop it, now I'm giving it gravitational potential energy, but I'm also giving it elastic potential energy here. Let's see if we can get this to work. Here we go. 3, 2, 1. And of course, that's pretty cool. So when you give it not just gravitational potential energy, but also elastic potential energy, you can get that fun result. All right. So here's another example. All right. You got balloons, right? So when you blow air, so you're taking chemical energy from your food, you do mechanical energy, you force your lungs to make air go into a balloon, you inflate the balloon stretches. You've given it elastic potential energy, and it's going to go back. Well, you can do that with fun ways. So here, for example, they made toys. By the way, almost all toys are science. A lot of them are physics, and toys are kind of fun. Now, this one is a little broke, so it might not work very well. But what I've got here is I've got some air stored into the elastic potential energy is now in this balloon. I'm going to uncoil this. And again, this one's a little broke, but you get the idea. It's releasing the energy that was in that balloon. It's forcing the air, which is making it go through these, making that spin. And you got a fun little toy helicopter. Here's a fun little car. Okay, it's got a car. Most cars, you make them go like this. Well, cars are funner if you make them go where you don't have to push them. All right, so earlier, for example, I was showing you this car, and I did it on the mini roller coaster. Well, have you seen these cars that you don't have to push them? That you can actually do something where you go like this and you pull it back and it puts energy into it? Well, there's springs inside of this. So this toy, you go like this and it will go because there are springs inside there. That's elastic potential energy. This car, if you blow air into it, set it down, it'll go because of the elastic potential energy stored in the balloon. Well, maybe you've played with a top. Well, if you look at a top, inside of a top, I'm going to try to let my camera person see this, there's a spring in there. There's a spring. And what happens is when you wind this top, that spring is coiling, and it's going to then release that energy. So if you make this and you wind this up, you're tightening that coil. So you are taking your chemical energy from your food, you're using mechanical energy of your hand, transforming it to mechanical energy of your hand. And when you transfer it to, now I'm going to transfer that to that spring. Now I've got elastic potential energy. Now it's been transferred to this object. Now I hit that button and we've got a top. All right. So that's pretty cool. All right. So a lot of times, like I said, people are coming up with ingenious, fun ways to make these toys. Here's a really neat thing that I really love. You can find these sometimes, and you can put these into a card you're going to send somebody. Freak them out. All right. So what you could do is you take, for example, something that is going to, you could put this in like a card or something. I don't think I have a camera. Well, maybe we'll just try it in this book as an example. All right. So imagine this book is an actual card instead of a book. And what you do is you can see here, there's a rubber band on there. And what I'm doing is I'm tightening this, and I'm taking my chemical energy from my food, and I'm using mechanical energy of my finger to wind that. I'm now storing energy into that rubber band. Take this, you put it in something like a card instead of a book. Like I said, person takes card out of the book, and all of a sudden they do this. And they are like jumping because they think inside of your card was this butterfly or something that jumped out. So we got all kinds of energies that we're talking about. So let's do 2 more for fun. All right. So coronavirus, right? We got all this COVID-19. You're supposed to socially distance. Well, Mr. Callahan came up with a way to play Frisbee by himself so that I would not need to endanger myself. So what I got here is I got a flip flyer disc, and I've got this piece of elastic that I put on it with this bead. All right. And what I'm going to do is I attached a little, like almost like a hair scrunchie type of thing to my finger here. And you can see this has got elastic potential energy. So if I take my hand and I flip my hand, well, what I'm going to do is I can take my chemical energy from my food, I'm going to turn it into mechanical energy. That's an energy transformation, all right? And then I'm going to flick my wrist, and when I flick my wrist, the Frisbee is going to fly out. Well, that's also going to make this elastic stretch, giving it elastic potential energy, and it should come back. So I've transferred my energy to this piece of elastic, and then it's going to transfer, the elastic is going to transfer when it gets as far as it can get, it's going to transfer its energy to the Frisbee, and it's going to come back to my hand. We'll see if Mr. Callanan can actually catch it. Oh, I almost caught it. Let's try that again. And so I can play Frisbee by myself. And the good thing about this is, even if I don't catch it, like that time I caught it, that time I missed, didn't matter. I still don't have to retrieve it. So maybe you could play some Frisbee by yourself during this crisis that we have here. Last one for fun today. All right, last one for fun here. We got a little neat car here, and I'm gonna let my cameraman show you this a little bit. But what we got here is this little wheel thing right here. It has this little catch thing on it here. And so what I'm going to do is I'm going to take this rubber band, and now I'm going to take chemical energy from my food, and I'm going to wind this, turning it into mechanical energy. And now I am putting that into this rubber band, and now this is getting and storing energy as elastic potential energy. And I'm going to set that now down, and this is now going to take that. It's going to take the elastic potential energy that's in the rubber band. It's going to transfer it to the car, and hopefully it'll come right at us and fall off the table. Here we go, unless it spins too fast. Oh, kind of spun out, but there we go. That again is another fun toy. So this is a little car that I built. I didn't build it during this time, but if you are going to do this, you need some simple materials. I had used some rubber bands here to make this on the wheels. I built this a little while ago, so mine's not staying quite as well as it needs to there, but that gives it some traction. That one's spinning out a little bit, sorry about that. But let's try it one more time. We'll see if I don't give it quite as much energy. Maybe it'll go a little bit better. Here we go. So there we go. So fun with different types of energy, all right? Lots and lots of examples today for you of gravitational potential energy and elastic potential energy. But as we were doing it also, hopefully you also got to enjoy and see some energy transfers and transformations like we talked about from last week. So this week, just so you know, like I said, what's going to happen on this week's Google Form Check at the end of the week is I'm going to put pictures of different things in, and you're going to have to be able to figure out what type of potential energy it is. So today we focused on gravitational potential energy and elastic potential energy. Tomorrow we're going to focus on, we're going to focus tomorrow on electric potential energy. And then on Wednesday, we're going to focus on magnetic potential energy. And then we'll do a little bit of review on Thursday of all types of energy, but we'll also do some chemical potential energy. And so we got all these different types of potential energy. We got gravitational, elastic, electrical, magnetic, chemical, and there is one other one that I can't really demonstrate, which is nuclear potential energy, but we'll talk about that a little bit on Thursday as well. And then on Friday, what will happen is I'll just start showing pictures, probably 8 or 9 different pictures of different types of potential energy from the week, and you will have to determine which one it is. That's what we're doing. Hopefully you enjoyed today's video. Have a great day.